In this lesson, we're going to be learning about measures of central tendency, or sometimes they're just called measures of center. And what measures of centers what measures of center are is it is a value that represents a typical data value or a central data entry. There are three common measures of central tendency, and they are the mean of a data set. The mean can also be referred to as the average of a data set. The median of a data set, which could also be referred to as the second quartile, but we're learning about that in a couple lessons, and the mode of a data set. And we're going to start off by learning about the mean. So the mean, also known as the average, is the sum of all the data entries divided by however many entries there are. This notation, this sigma, this weird looking Greek letter, it's a capital sigma, X, all this means is that you just add up all of the X's that are in that data set. And we'll see an example of that right here in a second. So if I'm working with population mean, if I have population data, the symbol for the population mean is the Greek letter mu. It is not an M, it is not a U, it is a mu. You can type that on a keyboard. We will talk about that later in the course. And it's equal to the sum of all the X's divided by the size of the sample. The size of the sample is a capital N because it would be the population size. I said size of the sample. I shouldn't have said that. I should have said the size of the population because I'm talking about the population mean. But if I'm talking about the sample mean, that is read X bar. It is an X with a bar above it. It is written as the sum of X over N, little n. And little n is just the sample size. So they're the exact same formulas. It's just written differently depending on whether you're talking about population or sample. That distinction is not to be taken lightly. We will spend the rest of the course talking about the difference between population symbols and sample symbols. So we have to know that mu is for population and that X bar is for the sample when we're talking about the mean. Now let's look at an example of how to compute the mean by hand and how to also do it on StatCrunch. So we have some data right here for a sample of adults that are participating in a weight loss study. We want to know what the mean weight is. Because they said it's a sample of adults, I'm going to say this is X bar, calculating the sample mean. I need to add all the X's and divide by the size of the sample. So adding all the X's, I'm going to add all of the values that were given to us in the data set. So we were given, looks like 7 different values, and we're going to add them all together. And then we're going to divide by 1, 2, 3, 4, 5, 6, 7. Yes, the size of the sample. So that is how we compute the average of a data set. I got 1,810 divided by 7 gives me approximately 258.57 pounds. So that can be interpreted as the average weight of the adults before they started the weight loss study is 258.57 pounds. And we can see that here. So notice that I didn't just say the average is 258. I didn't just say the mean is 258. From just reading this sentence, the average weight of an adult before starting the weight loss program is 258.57 pounds. I know exactly what the question was asking, and I know exactly what context the question was around. That's how you want to make sure you're writing your interpretation. Generally speaking, I am not going to ask you all to do this by hand, calculate this mean by hand. We could be working with a very large data set. In this example, we only have 7 data entries, but it's possible that we could have 100 or 500. It could be very time consuming and very easy to make a mistake calculating that mean. So instead, generally speaking, we're going to do that in Excel. So just to make sure we're all on the same page on how to access that, from my Outlook page, I'm clicking on these 9 dots and I'm going to click on Excel. Once that loads, I will click on the green button that says Create Blank Workbook, and that'll give me a blank Excel file to work in. Once I have that blank Excel file, I'm going to manually type in the data that we calculated the mean for. Sometimes for larger data sets, I will give you a link to the data that you could copy and paste into Excel. Do not make the mistake I just made. Make sure you type the data correctly. But in this case, the data is small enough where we can just type it in. So let's talk about how to find the mean or the average. It doesn't matter if you want to put mean or average. We can use those words interchangeably. But to do it in Excel, we always start with the equal sign, and we need the average command. When I click on it, it does open up parentheses for me. I want the average of column A. So you could just click on column A to get it like that. Notice it gives us the exact same value we calculated by hand. Alternatively, you could type average, open parentheses, and just highlight your data, and you'll get the exact same value. The last thing I will mention about the mean is that it can only be calculated for quantitative data. So what I mean by that is that we can only calculate the average of numbers. We have to have number data. We can't have qualitative data like a list of names. We can't calculate an average name there. So the mean is reserved specifically only for quantitative data. The next measure of center that we'll talk about is the median, and the median is the value that lies in the middle of the data when the data set is ordered. So it is the value that tells us 50% of the data is larger than this, and 50% of the data is smaller than this value. So it divides the data equally into two different parts, and we're going to look at two separate examples of calculating the median because we do it a little bit differently depending on if there's an odd number of entries or if there's an even number of entries. So looking at example 2 first, we're going to find the median weight listed here. So I'm going to begin by ordering the data. When you're finding the median by hand, you always want to start off by ordering the data. So the smallest value is 223. And then we have a 235, followed by another 235, followed by a 268, a 274, a 285, and then a 290. So I just listed the data in order. Now that I have the data ordered, I'm going to find what's in the middle by crossing out one on the left and then crossing out one on the right. Cross out another on the left, cross out another on the right. So we have 2 on both sides crossed out. Now I'm going to cross out 3 on both sides, and I can be left with exactly 1 entry in the middle to see that the median value of this data set is equal to 268. So I could write that, I can now interpret what that means. And I'm going to do this interpretation in context. So I can say the median weight of the weight loss, they were weight loss participants, right? I'll just say of the adults. The median weight of the adults before the weight loss program is 268 pounds, right? That is not an interpretation. That's just a statement. That's just me saying that's what the median is. I'm going to interpret the median. What does the median mean? So that means that half of the adults weigh more than 268. I lost my typing. Weigh more than 268 pounds, and half of the adults weigh less than 268 pounds. I'll fix that in a second. That's what, not weight, but weigh. That is how we interpret the median, okay? So this is, again, very important. We're going to have lots of assignments in this course where we are interpreting our descriptive statistics. The median is a statistic, and it is descriptive. It describes the data set. It describes the midpoint of the data set. And how we interpret that is that half of the adults weigh more than the median and half of the adults weigh less than the median. Now let's look at another example. We're going to again calculate the median here, but let's say that one of the participants who weighed 235, or wait, someone left. I don't know who. The participant that weighed 285 isn't participating anymore. Okay, so that's not in the data set anymore. I'm going to still begin by ordering the data. 2, 2, 3. It'll be the same order as before, just that we won't have the 285. So it'll just jump to 290. We only have 6 entries now. So cross out on the left, cross out on the right, cross out on the left, cross out on the right. If I cross out any more, then I don't have any data left, so I don't cross out anymore. What I do now is I'm going to calculate the average of these values, okay? When the data had an even number of entries, like this does, this has 1, 2, 3, 4, 5, 6, even number of entries. The median is the mean of the two middle entries. So here's the two middle entries. We're going to find the mean of these numbers by adding these numbers together and dividing by 2, because there's 2 of them. So 235 plus 268, 503, and 503 divided by 2 is 251.5. That is the median of our data. And this is in pounds. Let's put some units on here. Pounds. Okay, so I could also interpret that very similarly. I'm actually just going to copy and paste this. And I'm going to say this median is 251.5 pounds, which means that half of the adults weigh more than 251.5 pounds and half of the adults weigh less than 251.5 pounds. Okay, that's how the same interpretation that we had before when we were interpreting the median. Just notice that when the data set had 1, 2, 3, 4, 5, 6, 7, an odd number of data points, we didn't have to calculate any averages. So here we had to come in and calculate an average. You don't have to do that when the data set has an odd number. I am now back in Excel to show you how we can calculate the median in Excel without actually listing the numbers in order and crossing them out. So for that example 2, the data set was the original data set that we used the first time around. So I'm just typing equals median to get the median command in Excel. And I'm selecting all the data in column A. In fact, let me organize this. So first I'm just going to put median. And then I'll go to the next cell over and type median. I want the median of all the data in column A. I get the same value we got in example 2, the 268. Alternatively, you can type equals median and just select that array from cell A1 to A7 and get the same value. To verify the median we got in example 3, if you look at the data for example 3, it's a little bit different. There's only 6 data points because the 285 is not there. So I just deleted the 285 from the B column. And now let's see how to find the median. I'll just label this example 3. This isn't anything formal, right? I'm just trying to show you how to calculate the median in Excel. Notice that now when I calculate the median for column B, I do get 251.5. Now, if you're going to, I think this will still work, highlight and select the data, I think it will just jump over the fact that that's empty. Perfect. And we once again get the median of 251.5. So we can absolutely use Excel to calculate the median, especially if we're working with a really large data set. Because if we have 500 data values, you are not going to want to list them in order from least to greatest and find the one that is in the middle. The last measure of central tendency that we will talk about is the mode. And the mode is the data entry that occurs with the highest frequency. So it is the data entry that shows up the most. If no data entry is repeated, then the data set would have no mode. Or if no data shows up with the highest frequency. And it is possible for a data set to have 2 modes. Example 4, let's find the mode of this data set. Sometimes it's helpful to order the data when you're looking for the mode. This is the same data that we had from before. I've already ordered it. We can see that 235 shows up twice. It has a frequency of 2, which is higher than all the other values, which only show up once. So the mode would be 235 pounds. So I could write a sentence to interpret that. I could say the mode of the data set is 235 pounds. That is not an interpretation. That is just simply a fact. Reading that does not really tell me anything about the data set, except that 235, that the variable is measured in pounds. But I'm going to go on to say the data entry that shows, I know you all can't see that, up with the highest frequency is 235 pounds. You could even then go on to say that it shows up twice. I can add in parentheses here, 2. That tells me what the mode is, and it also tells me what the mode means. So that's not even fantastic. The data entry that shows up, a better way to say this would be the most common adult weight in the data set is 235 pounds. That's even better description or interpretation because it tells us what the data is about. Right, so remember, when we're interpreting this data, I guess I just made a pretty common mistake. When we're interpreting this data, you don't just want to say like, of the data set or from the data set. Don't you tell me what the data is about. What is the data about? The data is about adults' weights. Before they started this weight loss program, it was collecting their weights. We should be able to tell that when we read the interpretation of the data. I just want to give a couple. Let's look at this last example here on the mode. This is very easy because the table is sorted by frequency, and we can see that the one with the highest frequency is the Democrat. We're just being asked, what is the mode of the responses? Democrat is the mode of the responses. It's the answer that came up the most when people were asked at this debate what political party they affiliate themselves with. I just want to give you a couple more examples of data and finding its mode. Say I had given you a data set of 2, 1, 3, 1, 3, 2. Every entry of this data set shows up with frequency 2, right? 1 shows up twice, 2 shows up twice, and 3 shows up twice. None of them show up with higher frequency than the other, right? Like if I were counting their frequency, the data points for 1, 2, and 3, they all show up with frequency 2. None is the highest, and so there would be no mode because none of these numbers are larger than the other. Another example, say I gave you a data set with 1, 2, 1, 3, 3. Well, now the data values that show up are 1, 2, 3. Let's look at the frequency with which they show up. 1 shows up twice, 2 shows up once, and 3 shows up twice. So this has 2 modes. This data set is bimodal because there are values that show up more than other. Both 1 and 3 show up with the highest frequency. So the difference here is that 2 is bigger than 1. So there is a largest number here, but 2 is not bigger than 2 among these numbers. None of these numbers is the largest. So that's the difference between a data set that has no mode and a data set that has 2 modes. Now that we have learned what the mode is, let's see how to find it in Excel. You can probably guess I'm going to type equals mode. Open up parentheses. I want the mode of that data from column A. It does tell us that the mode is 235. That's the data value that showed up the most. Okay, so far we have talked about the three most common measures of center. We've talked about the mean, we've talked about the median, and the mode. Now we're going to talk about how do we know which one is best? How do we know which one's best to use? And that depends on whether or not the data has any outliers. So an outlier is a data that will be fixed by the time you see that, is a data entry that is far removed. So basically just far. Very different from the other entries in the data set. And I know that's a very loose definition. Like, well, what do you mean it's very different than the other data in the entry set? How do we define that? We will define that later in this course, but for now, this definition will work for us. So we're going to look at an example where we determine which of these data entry, which of these points is the most descriptive of the data set. Which of these best describes the data set between the mean, the median, and the mode? there's advantages to using the mean, and there's also disadvantages to using the mean. One really good advantage of the mean, what makes it very popular among people who study data, is that the mean considers every entry of a data set. You have to average all of the numbers. You have to add all of those numbers together to get the mean of a data set. Here's a quick example. Let's give a small example. Let's say I have a data set of 2, 5, 7, and 4. Okay, 2, 5, 7, and 4. If I average those numbers together, 2 plus 5 plus 7 plus 4 is 18, and 18 divided by 4 gives me 4.5. The average of that number is 4.5. So I added all those numbers together and divided by 4. Let's look at another example. Let's say this time I look at 2, 5, 7, 4, and then 100. Okay. So I added in this huge number. So 2 plus 5 plus 7 plus 4 plus 100 divided by 5 now gives me an average of 23.6. Look at that difference. Okay. Almost the exact same data set. I just added in 100, and the average has now gone way up to almost 24. But let's see what would have happened if between 2, 5, 7, and 4, what if I would have just added in 6? How far from the original average, this is the original average that we saw, and you don't have to write all this down, I'm just proving a point here, but how far from the original average would we have gone? The average of 2, 7, 5, 4, and 6 is 4.8. That's not that far at all. 4.8 and 4.5 are pretty close. So I add in 6, and the mean doesn't change that much, but I add in this outlier because that is very different from the rest of the data, and the average changes significantly. So that's a downfall of using the mean, because the mean is greatly affected by outliers. Outliers change the average quite dramatically. So what we're going to do is we are going to look at this data set. It shows the sample ages of students in a class. We're going to find the mean, median, the mode of these ages, and we're going to determine whether or not there are any outliers. Once we know whether or not there are any outliers, we will answer the question of which measure of center best describes a typical entry in this. To begin to calculate these measures, I'm going to use Excel. So in the blank note sheet, there's a hyperlink on that table. You can control click it, or you can right click it and select copy hyperlink. Once you have the hyperlink copied, I already opened it up, but you will just paste it into your address bar in whatever browser you use, and it will open up the data for you in Excel. So this would be very common in the course, seeing data in the course. I think I just messed up my window. Seeing data in the course that's hyperlinked, and you just opening that link to get the data in Excel. So now that we have the data in Excel, let's quickly calculate our mean, median, and mode. We calculate the mean using the average command. Make sure you put that equal sign first. So I see that the average age of a student in the class is 23.75. I'll use the median command on column A to see that the middle age of students in the class is 21.5. So about half of the class is older than 21 and a half years, and half of the class is younger than 21 and a half years. And then finally, I'll use the mode command to see what the most frequent age that shows up in the class is, and it is 20. So we've calculated our measures of center. We're now tasked with figuring out which of these is a best description for this actual data set, which of these numbers best describes the data. And one way to start to think about that is to visualize the data, look at a graph of the data. So one of the things I'm going to do is I'm going to go and create a box plot for this data, because there's also a question on that note sheet that's asking if we have any outliers. If we have outliers, we need to be mindful, because as we have seen, outliers can drastically change the mean. So I have the data selected. I'm going to insert. I'm under statistical, and I'm clicking on the box and whisker plot. Just for good measure, I'm going to do what we're supposed to do. I'm going to title this box plot. This is a box plot for ages in the class. So I'll close the chart title. The vertical axis needs a label. Those numbers, 0, 10, 20, 30, 40, those are ages. So I am going to, under vertical axis, I'm already under vertical axis here. I'm scrolling down to turn on the axis title, and I'm labeling that axis ages, and I see that difference pop up there. Okay, great. So now this is a much better labeled box plot, but really all we were concerned with were, are there any outliers? And when we look at this box plot, I can see this dot all the way up here. That's an outlier. Well, what value is that? If you look across, that's between 60 and 70. That is this 65 in the data set. That is an outlier. If you looked at your upper fence and your lower fence, you would see that that was an outlier. So what that means is that that 65 is drastically changing the mean of this data. Let's see what the mean would be. I'm going to put mean without outlier. Let's see what the mean would be without the outlier. If I calculate the average of just these values, so I'm excluding the 65, notice I did not grab the 65, our mean has dropped by about 2 years. 2 years, 2 ages, 2 years smaller, 2 ages smaller. What am I saying? When we get rid of the outlier, our mean is about 2 years smaller. So that was a pretty significant difference. If we think about what's going on here, we're talking about students in a college class. A 65-year-old, that's a non-traditional student. They are pushing the mean up higher than it would be if they weren't in the class. So when I look at the new average without the outlier, I can see that perhaps the median or the mode would have been a better representation of this data rather than the mean, because the mean with this outlier is not really telling the true story because it's inflated. So if we have data sets with outliers, we're going to tend to focus more on the median, because we're not always going to have a mode, but we're going to tend to focus more on the median, the middle point of the data, rather than the mean, because with an outlier, our mean is not really indicative of what's actually going on in the data set.